In this video, I'm going to go over using arrow notation. We're not really describing domain or range, but we're describing the behavior of graphs of functions. So I'm going to do a little graphing here. They're going to be crude drawings, but just deal with it. But we're going to go over what these mean, right? X arrow A with the little minus sign there. What does that mean? It means X approaches A from the left. Okay. And this is X approaches A from the right. Now, what do I mean when I say from the left or from the right? Well, as always, I picture a number line. Usually you might, on the Cartesian coordinate plane, there's also the vertical, but mostly just picturing the horizontal because that's what the X coordinate is, right? That's the horizontal part. Well, A is one of those spots on that horizontal line. And as we're approaching A, because this whole thing is X, right? X, 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 X. Different values of X, but it's still X. A is one constant. As we're approaching that A, what does the function do? So we're saying as X approaches A from the left, from the negative side, right? What does f of X do? That's what we're talking about here. All right, let me just erase this real quick. Now, that's why we have f of X. All these are the same, right? Infinity, minus infinity, A from the left, A from the right, positive infinity, negative infinity, right? And they're all kind of describing what the output is doing based on where the input is going, right? So start with an easy one. F of X equals X. That's just a simple diagonal line, right? Well, as X approaches, I guess in this case, infinity, because there's nothing stopping this line. It just goes off to infinity in both directions. That's why we have the arrows on it. So as X approaches infinity, for a simple line graph, f of X approaches positive infinity, right? Because this axis would be f of X. So as X gets larger and larger, f of X also gets larger and larger because it's going up to the right, right? And as X approaches, I didn't really write that very well, as X approaches negative infinity, what does f of X do? F of X approaches negative infinity. That is as simple as it gets. It will make more sense the more complicated the graph gets, right? So why don't we do that? Why don't we describe what the more complicated ones are doing? Let's just erase that whole thing. If you need it, you can rewind this video. All right, X squared, what does that graph look like? Looks like this, right? Oh. Okay, kind of the same thing. X approaches infinity, or as X approaches positive infinity, f of X is also approaching positive infinity. That's the same as the other one, right? Well, where's the difference? Well, maybe it's in this part. As X approaches negative infinity because it's getting smaller, right? Going off in the negative direction. F of x is not getting smaller. It's still going up. So it's approaching positive infinity. So that one change describes a parabola as opposed to a line. Interesting. All right. What about f of x equals 1 over x? That is a bit more complicated of a graph. It looks like this. Right? Because as x gets larger and larger here, start over here, as x approaches infinity, what happens to f of x? Well, it approaches this x-axis, right? Which on the y-axis is what? It's 0. So f of x is getting closer and closer to 0 from the positive side, right? Because we're above it. F of x, right? Negative f of x. Okay. But it never quite touches it. It just keeps approaching it, right? Because we're taking 1 and we're dividing it by a larger and larger number. The larger the denominator, the smaller the number, but it will never be 0. I mean, divide 1 by a googolplex, you will just get 1 over a googolplex. You will not get 0. Anyway, next part of it is this part. As x approaches 0, something happens. So that's why, say as x approaches 0 from the right, that's what the little plus means, is from the right. And in this case, our a is 0. It's the y-axis. F of x approaches what? Positive infinity, right? It just keeps going up and up and up. But x will never quite reach 0 because that would make this undefined. So x cannot be 0, which means that the y-axis itself is an asymptote. You know what an asymptote is? It's kind of a restricted value of a function. You just can't reach it, right? Same goes for the y-axis here. That's a restricted value as well. F of x cannot equal 0. 1 divided by something equals 0? I don't think so. Because if you tried to solve that equation, what would you get? You would have to multiply both sides by x, right? Well, that just gives you 1 equals 0 times x, which is not a true statement. That is why that is also an asymptote. Okay. So, now, the second part of the graph we need to describe as x approaches 0 from the left now, because we have to account for every part of it. It's kind of like listing out the domain and range of a function. F of x approaches what? Negative infinity. It keeps going down and down, 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 down. Now, as x approaches negative infinity right here, it just keeps going this way forever. F of x is getting closer and closer to that other asymptote 0 approaching from underneath. It's closer and closer to 0 approaching from the negative part of it, right? Because x is, you know, that horizontal number line, but when it comes to f of x, that's our output, or y if you prefer, but same thing. We have to think of it as the lower side is the negative part. That's why we're approaching from the underside, really. So it's kind of the opposite of the other side, right? As it approaches positive 0, we're going to infinity. As it approaches negative 0, it goes to negative infinity. As we approach negative infinity, we come from the negative 0. And as we approach positive infinity, we approach the positive 0. All right, we'll do another example, and this will all make much more sense. All right, one more example. This is a different function. It's f of x equals 1 over x plus 2 plus 3. Now, I will show you how we find these asymptotes in a later video. But for now, just know that this graph, oh, that was a terrible drawing. This graph looks something like this. And all we need to know right now is how to describe the end behavior of the graph, right? Because as x approaches positive infinity, f of x approaches what? What is this? Negative 2, positive 3? This is the point right here. F of x approaches positive 3, right? Because it's the vertical element. From what? The positive side, from the top of it. So we don't put a negative there, we put a positive. All right, so what happens here? As x approaches negative 2 from the right, right? It's coming from the positive side. F of x is approaching what? Positive infinity, because it's going up, right? Okay. All right. Now, as x approaches negative 2 from the other side, the negative side, f of x approaches what? Negative infinity. It's not so bad. And as x approaches negative infinity, f of x approaches what? Positive 3 again, from underneath, from the negative side. That is what we're talking about. We're talking about the end behavior of the graphs. I'm using arrow notation. Thank you for watching.